Welcome everyone to the IDF webinar on dairy's role in sustainable food systems. Over the next 90 minutes, we'll explore the key components of healthy, sustainable diets with a particular focus on the latest research on dairy foods. The discussion will highlight the importance of nutrient adequacy and bioavailability within sustainable diets, particularly for vulnerable life stages and populations, and we'll explore the acceptability of animal source foods, including dairy foods, in local contexts around the world. I'm Katie Brown, President of National Dairy Council in the US, and I'll be the moderator for today's webinar. Before we begin, I'd like to go over a few notes. This session is being recorded and the recording will be available afterward. Please keep your microphone muted and your camera turned off. If you have any questions, feel free to type them in the chat box. We will address them during the Q&A session after the presentations. And lastly, if you'd like to follow along more easily, you can enable the transcript option to read the subtitles provided by the application. We're joined by three leading experts in this space, Drs. Laura Iannotti, Adam Drewnowski, and Stefan Peters. Dr. Iannotti is a leading expert in maternal and child nutrition, the inaugural Lauren and Lee Fixel Distinguished Professor at the Washington University School of Public Health. She's the co-director of the FAO Food and Research Mission and director of planetary health at WashU's Center for the Environment. Dr. Iannotti holds a PhD in international health and nutrition from Johns Hopkins Bloomberg School of Public Health, and an MA in foreign affairs from the University of Virginia. Today, she'll be discussing the role of dairy and other animal source foods in contributing to the Sustainable Development Goals and global nutrition milestones, as well as in supporting nutrient adequacy across the life stage, particularly for vulnerable populations. Dr. Adam Drewnowski is a globally recognized expert in obesity and social consideration in diet and health, serving as professor of serving as professor of epidemiology and director of the Centers of Public Health, Nutrition, and Obesity Research at the University of Washington. He's the inventor of the Nutrient-Rich Foods Index. He holds an MA in biochemistry from Balliol College in Oxford and a PhD in psychology from the Rockefeller University. Today, he'll be discussing dairy's role in supporting the 4 domains of sustainable food systems with a particular focus on the health, economic, and social domains. Our third expert is Dr. Stefan Peters, Nutrition Science Manager at the Dutch Dairy Organization, where he leads research on healthy, sustainable diets. Dr. Peters previously worked at the Netherlands Nutrition Center as a science and quality manager and participated in the development of the current Dutch food dietary guidelines. Today, he'll explore innovative metrics for evaluating foods through the dual lens of environmental impact and nutritional contributions. Again, please feel free to drop questions into the chat throughout the presentations, and we'll do our best to address them during the Q&A. And with that, let's get started. I'll turn it over to Dr. Iannotti for her presentation.
Good morning, good afternoon. It's very nice to be here. Thank you for joining. As Katie said, I'll be talking about dairy and other animal source foods in achieving Sustainable Development Goals. I'm Laura Iannotti, and Katie has already given you my titles. All right, very briefly, my lab is the E3 Nutrition Lab. We focus on maternal, young child nutrition, testing innovative interdisciplinary solutions that embrace each of the 3 E's of equity, evolution, environment. We do field-based research. We bring that up to the global level to influence policy. So I'll start with very briefly the nutrition situation and the bioavailability of animal source foods, which Adam has already talked about. Then I'll go into research that we've done with FAO on the terrestrial animal source foods report and 2 Kenya case studies, and then conclude with policy impacts and the importance of milk and dairy for SDGs. Okay, so around the world, 1 in 5 children are stunted and 250 million have stunted development. But on the other end of the nutrition spectrum, over 2 billion people now are overweight and obese. A study by Stevens et al. Just showed that over half of all children around the world have deficiencies in vitamin A, iron, and zinc, and 2/3 of women have deficiencies in iron, zinc, and folate. We are not yet to the point where we've reached the World Health Assembly And I will propose to you that we need animal source foods to attain these World Health Assembly global targets. Malnutrition and global burden of disease remains a leading risk factor. So of the top 10 risk factors for mortality, nutrition-related factors in the yellow circles number 5 for children and 6 for adults. I'm not going to go into this in too much detail, again, because previous presentations have talked about that, but these are the limiting nutrients in certain populations around the world, and these can be found in bioavailable forms in animal source foods. So the bioavailability is the proportion of the nutrient that's absorbed and metabolized. And this depends on the chemistry of the nutrient, but also the interaction with other nutrients, and very importantly, the life cycle phase. So vitamin A is a good example. Retinol is the form that we absorb, found in animal source foods, and we need about 12 times that beta carotene, even 24 times in certain carotenoids to get to one retinol equivalent. One key takeaway I hope that you leave with this presentation is that nutrition varies in the life course. And there are certain phases where animal source foods are especially important. And I would say for the first 1,000 days of life, pregnancy and lactation, school-age kids for the developing brain, and then older adults. And I'll show you that in a minute, the reason why. So the terrestrial animal source foods report was done by FAO. I was the lead consultant on this, and this was done on the request of the Committee on Agriculture and the member states around the world. 2 papers have now been published if you're interested, both in nutrients, one on the epidemiological benefits, health outcomes arising from terrestrial animal source foods, and the other on the nutrient composition differences based on various characteristics. So animal source foods in our global food supply are increasing for milk, eggs, pig, and poultry meats, but that is true for some populations and not all populations. It's decreasing or stable for bovine, mutton, goat, and other meats. Animal source foods provide about 18% of all food energy and 34% of global protein. But as I mentioned, there are disparities within and regionally for consumption of these foods. Animal source food consumption by young children in the previous 24 hours is what you can see in this figure, and the wide disparities that exist between the poorest quintile versus the wealthiest in the yellow box. Quite evident for dairy foods. And this is having health repercussions. So the nutrient and bioactive factors in animal source foods were surveyed, were assessed in this large report. And what we showed is that nutrient composition varies by livestock species, feeding system, livestock breed, production environment. And this is, so the bottom line is it's important to diversify consumption and production. Some of these nutrients have been touched on already by Adam and Stephen. Protein, the high quality is indicated by DS, we use instead of PDCAS. Docosahexaenoic acid, extremely important. And then the vitamins of A, B12, choline, calcium, iron, zinc, and selenium. As we mentioned, the bioactive factors, the so-called dark matter that we know are linked to health outcomes that are present in animal source foods and not plant-based foods. Here's an example for differences across milk from different livestock species. And you can see by the color of the shading, the differences in those nutrients by animal. Here we did an epidemiological assessment. And what you do in these assessments is you use the best available evidence first. So systematic reviews and meta-analysis, randomized controlled trials, and you look for the effect of the milk and dairy products on health outcomes. And we found substantial evidence on those positive health outcomes across all life course phases for milk and dairy. For pregnant women, increases in offspring birth weight, birth length, head circumference. For school-age children and adolescents, increases in height, decreases in overweight and obesity, increased bone mineral content and density, B12 concentrations, and arm muscle area. And then skipping to older adults, this was very important finding that there's a consistent across the evidence base decrease in sarcopenia with consumption of milk and dairy products, decrease in fractures, frailty, dementia, Alzheimer's disease, and an improvement in cognitive outcomes. So just very briefly, some older work that we did among pastoralists. Milk is integral to the pastoralist diet, but unfortunately it has decreased significantly with health implications. So among the Samburu, dietary changes have emerged because of market integration, extreme drought and climate change, diminishing pasture availability, and civil conflict. Our study found that milk, which once provided over half of calories, now only provides 10%. Maize is the other 52%. And yet, milk consumption is associated with increased anthropometry, increased BMI Z-scores in a positive way. Next steps are intervention studies. Also in Kenya, we did a study with fish, and this study was a cluster randomized controlled trial in small fisher households, and we were targeting 3 different outcomes: child nutrition, ecosystem health, and livelihood. So we used team science, combining these different disciplines, and our study had a win-win-win. We increased child nutrition, height for age Z-score, and increased diet diversity. We improved ecosystem health, increasing fish length, decreasing trophic level, and increasing catch per unit effort. And we increased livelihoods and catch value. This was a combined intervention of behavior change and a modified fishing trap, and demonstrated that, in fact, we could positively affect ecosystem health and child health. So to conclude, malnutrition prevails globally, exacerbated by climate change and humanitarian crises. A diverse array of animal source foods can address malnutrition, and specifically SDG 2, notably nutrient deficiencies, if we rebalance consumption patterns around the world. Milk and dairy products are linked to positive health outcomes across all stages of the life course. Research is needed on a broader range of animal milks and products, and the exact dosing and quantity needed. And ultimately, milk and dairy are important for attaining SDGs and the World Health Assembly nutrition milestones. Policy impacts have now been seen through this FAO report, but recently released WHO guidelines for complementary feeding. Actually, milk and dairy products appear in 2 of those recommendations, in 2 and in 4, and then the UN Nutrition Report on livestock-derived foods. At WashU, we've started a new initiative called FARM, Food and Agriculture Research Mission, where we will continue to do this work to advance interdisciplinary solutions for a healthier food and healthier planet. And with that, I'd like to conclude and say thank you very much.
I'm here in Paris after the ICN Congress, and I think you are everywhere around the world. So good morning or good afternoon. It's a wonderful afternoon here in Paris. And the topic today is a reality check for the Eat Lancet 1.0 and 2.0. So this is my outline. I will talk about the animal and plant protein sources in the American diets. I will provide you with, as I said, a reality check for Eat Lancet 1.0 and the upcoming 2.0 versions. I will discuss protein quantity versus protein quality and deal a little bit with the USDA protein equivalency charts. The one important point I want to leave you with is this. There are actually 4 dimensions of sustainability and not just 2. Remember that. 4 dimensions: nutrition, economics, society, and the environment. 4. And each of those dimensions has sets of metrics and measures. And then I'll deal with the issue of dairy proteins in the Eat Lancet diet to finish off. So let's start. So this is the source matrix, so to speak, of proteins in the United States diet. Take a look at the left. At the left, you see foods available for consumption from the USDA. This is now in grams, rather not in grams, this is in percentages. So notice that 35 of proteins come from the protein food group. Another 13% comes from milk and dairy, which are not in the protein food group. Another 7% comes from mixed dishes dairy, which very often in American context means pizza. Then you have proteins coming in from mixed dishes with meat, from grains, snacks and sweets, vegetables, beverages, fruit, and other. But of course, notice that 55% of protein in the American diet comes from the protein food group and from milk and dairy. What you see on the right is a slide that we used a long time ago to develop the concept of nutrient density. These are the nutrient-dense foods. And notice the prominent place in the center for milk and yogurt and cheese and eggs. You see the other protein sources around, including beans, but also seafood, poultry, red meat, and so on. But I will focus on the protein food group and take a look again on the USDA data on the left. This time, they give you data in food availability in grams per day. Again, these are not consumption data, these are the availability data. There's a distinction, we can talk about those. So take a look at red meat. Beef, 49 grams, pork, 36 grams, chicken, 68 grams, and then smaller amounts from peanuts and eggs and seafood and tree nuts and pulses and soy food. Pay attention to those, and of course those foods are all listed on the right, same picture, but now I'm showing you plant proteins and animal proteins. So take a specific look at red meat, beef and pork, and then chicken, and then the plant protein sources, peanuts and tree nuts and pulses and soy foods, which are all a part of the protein food group. But notice, of course, dairy is not officially a part of the USDA protein food group. It is a separate group on its own. And now let's start talking about Eat Lancet. This is a nice picture, I think, from the Daily Mail, which now looks at the Lancet plate, the prominence given to fruits and vegetables and dark green vegetables and leafy greens, and a smaller amount of protein and a very, very small amount allocated to animal proteins. I have a better slide for you following, because now we can compare the reality on the left with the Eat Lancet 1.0 on the right. Take a look at the consumption of beef proposed by Eat Lancet 1.0, 7 grams per day. Consumption of pork, proposed consumption of pork, 7 grams per person per day. Then we go to chicken, reduced by half. Notice that the consumption of nuts is increased almost 3.5-fold. Eggs pretty much stay as they are. Then we move to seafood, which is actually increased almost 3 times. The consumption of pulses is increased 10 times. Soy foods more than 10 times. So my question is, those are extraordinary changes, and will they be feasible? Will this work? Eat Lancet proposes to add protein from milk. The requirement or the allowance for milk is 250 milliliters, which actually does happen to provide 7 grams of protein. Of course, as I will show you, 7 grams of beef or 7 grams of pork actually provides only about 2 grams of protein. So that, interestingly enough, dairy protein is the major protein source in Eat Lancet. All the meat proteins have been cut down to practically nothing. And there's a huge increase in nuts and pulses and soy. So there is talk about Eat Lancet 2.0. And in fact, the chief changes, such as they were presented at the meeting in Paris. But the changes really aren't all that drastic, other than looking at the midpoint of the range. Eat Lancet 2.0 proposes to extend it to the top of the range. So for example, rather than look at 7 grams of beef, we're going to be looking at anywhere between 0 and 14 grams of beef, and between 0 and 14 grams of pork, and between 0 and 58 grams of chicken, depending on local culture, tradition, and eating habits, something that was missing from Lancet 1.0. We'll talk about that later on. But take a look at the figure on the right, how it compares with the reality on the left. And again, take a look at red meat, beef, pork, take a look at chicken. And even with the increased amounts, I'm not increasing seafood, I'm just increasing meats, it is still very, very far from the existing eating habits that we currently have. So I started doing some of my own analysis. What I'm showing you now are data from different USDA sources in the United States. Those databases are in the public domain and can be downloaded from Food Data Central. So first database, the USDA Food and Nutrient Database for Dietary Studies, is the database that is used in What We Eat in America studies. That database has 6,581 foods, including 1,600 protein foods and dairy. Then I used USDA's own national food prices that were available for 3,000 foods, and there were prices for about 618 foods in the protein and dairy categories. Those are the prices that the USDA used to calculate the revised Thrifty Food Plan back in 2021. Then, of course, you're familiar with the protein digestibility corrected amino acid score. I got those values from the literature, and I looked at the protein equivalency charts from the USDA dietary guidelines. So let's see where that gets us. First big point is that some foods are richer in protein than others. What I'm plotting on the horizontal axis is grams of protein per 100 grams. On the vertical axis, you have energy density. Energy density, of course, goes from 0 calories per 100 grams to 900 calories per 100 grams. Water is 0, fat is 900 calories per 100 grams, and everything else is in between, depending on water content. So take a look at the horizontal scale. Foods which are highest in protein per 100 grams are going to be meats. Beef and pork and lamb and turkey and chicken. Cheese is very high in protein. Greek yogurt is high in protein, and so is cottage cheese. But milk, as you see here, has about 3 grams of protein per 100 grams. I also indicated plant-based milks, which have no protein worth speaking of. Beans, peas, and legumes, about 8 grams of protein per 100 grams, and nuts and seeds, with about 18 grams of protein per 100 grams. So this is the amount of protein per 100 grams. And as I mentioned before, you can do the mental calculation. 7 grams of red meat provides about 2 grams of high-quality protein, given that, for example, pork has about 25 or 26 grams of protein per 100 grams. You can work it out. But of course, not all plant proteins are nutritionally equivalent to milk or egg protein. The Food and Drug Administration requires the PDCAS correction for products intended for children under the age of 4 or for those foods that make a protein claim. I have found a number of plant-based proteins that do make a protein claim, which have not been corrected for PDCAS, but that is an issue for the FDA to resolve and not for us. Now, achieving high PDCAS can be a technical challenge because protein has to come from multiple plant sources to get it up to as close to 1.0 as can be done. And there are also micronutrient bioavailability issues for calcium, zinc, and iron from plant sources as opposed to animal sources. So take a look at the PDCAS table here on the right. You see cow's milk 1.0, casein 1.0, soy 0.91 or above. But the moment you start going to beans and chickpeas and peas and legumes, you're down to about 0.7. And when you go down to wheat, it's about 0.5. So then you start looking at the grams of protein corrected for PD-CAS, and notice that some foods move to the left, notably nuts and seeds, and beans and peas and legumes. Plant-based milks have no protein, so they don't really move. But notice that cheese and yogurt and cottage cheese and milk stay exactly the same as they were, and so do the animal proteins. So this is interesting when you start looking at the amount of protein per 100 grams. But what I did next to plan to look at protein corrected for PD-CAS on the vertical axis and protein in grams per serving. The FDA operates using servings, not 100 grams of calories, but servings, reference amounts customarily consumed. So here I'm plotting protein in grams per serving against protein after PD-CAS correction on the vertical axis. And there are two interesting things. One is that the nuts and the seeds and the beans and peas and legumes kind of move down because of the correction. Notice that dairy products stay where they are, but also notice that when you express dairy protein per serving, dairy produces as much protein as the other foods in the plant, in the protein food group. So I thought it was interesting because dairy is not in the protein food group, but it could be. It could have like a dual residence as part of the dairy group and also a valuable source of protein per serving. So that brought me to the protein equivalency charts published by the USDA. And the USDA says that the equivalency is really based on 7 grams of protein. So 28 grams, 1 ounce equivalent of beef and pork and lamb and chicken. Take a look at the middle column here. They do provide 7 grams of protein. I calculated that myself in a column on the right. And notice that the values for beef and pork and lamb and chicken and turkey and eggs are absolutely correct. But when it comes to nuts and peanut butter and seeds and beans, 28 grams of nuts or 2 tablespoonfuls of peanut butter are not nearly providing 7 grams of protein. You have to have a higher value, 76 grams of nuts, 66 grams of peanut butter, and a larger amount of beans. On the other hand, a serving of dairy absolutely does provide 7 grams of high-quality protein. So this is just something to say that the USDA protein equivalency charts need adjusting, and perhaps we'll see it in the next edition of the dietary guidelines. So the next issue, I'm going back to Eat Lancet, is this. Eat Lancet is trying to increase pulses, nuts, and soy and reduce animal products on a global basis because this is the planetary health diet. It's not for any one country, it's for the planet. And there is a problem. Eat Lancet went directly from nutrition and health to the impact on the environment, missing out the other dimensions of sustainability. The model to the left is the famous Barilla inverted pyramid. Maybe that was the idea. Notice the inverted pyramid produced about 10 to 15 years ago shows you the pyramid that we have, and then the inverted pyramid looking at the environmental cost of food production. That was very popular for a while, and it was the beginning of the concern with the environment in dietary guidelines. So Eat Lancet went directly from nutrition and health to planetary boundaries, impact on the environment, and greenhouse gas emissions. That was a little bit of a problem because, as I keep saying, there are 4 dimensions: nutrition and health, economics, food prices, social value, and then the impact on the environment. And in fact, Eat Lancet was criticized for missing out on the economics and society dimensions of sustainability. I don't know if that will come in Eat Lancet 2.0, but this is something to be discussed. So actually, I've been looking at those 4 dimensions. One important point about the 4 dimensions is that they are not additive. People say, is there a food which would qualify as perfect under each of those dimensions? And I say there is no such food. There could be such diets, but there is no one food. And that is because most nutrient-rich foods cost more and have a higher carbon footprint. The cheapest foods are based around refined grains, added fat, added sugar, and sometimes added salt. They tend to be nutrient poor, but they are cheap. Nutritionists never like when I say this, but the one plant food with the lowest carbon footprint, the lowest water footprint, and the lowest land use is sugar. Want to save the planet? Eat sugar. And then food choices, we have taste, satisfaction, cultural identity, dairy farming, and the embeddedness of dairy products in multiple societies across the globe. So 4 dimensions, not at all additive, sometimes a conflict with each other, but we need to pay attention to all 4 and not just 2. Now, each of those dimensions that I mentioned has metrics and measures. We have nutrient profiling, measures of the environment, greenhouse gas emissions, water use, land use. We look at affordability indices, food prices and diet costs. And then, of course, we look at shared value and culture and pleasure. I think in the Nutrition Congress, there was one session on gastronomy and pleasure. I wish there would be more. So this proposal, rather than look to the left, going from nutrition and health to impact on the planet, we should be looking at nutrition and health, impact on the planet, but also economics and society. And research needs to fill in those 2 additional pyramids. The society dimension right now does not seem to be populated. We need metrics and measures to be able to put into models. So just to start summarizing here, the 4 dimensions have measures. The first measure is nutrient density, and I will not go into specifics of nutrients, but nutrient profile models rate foods based on their nutrient composition per 100 grams, 100 calories, or per serving, and each food is awarded a single score based on negative nutrients, positive nutrients, or some combination of both. You're obviously familiar with Nutri-Score, the Health Star rating, perhaps the guiding stars, and other systems that are used to assess the nutritional value of foods. And nutrient profiling, of course, can be applied to individual foods, meals, menus, and to total diets. So just some basic points here. Nutrient-rich foods provide more nutrients than calories. Foods that are nutrient poor provide calories but no nutrients. Take a look here at data from the US about the percent of daily intake of vitamins and minerals from dairy foods. As shown by the red line, dairy foods provide about 10% of the calories. Take a look at the amount provided of vitamin D and calcium and phosphorus and vitamin A and B12 and saturated fat, and of course protein, zinc, potassium, and so on. So by definition, dairy foods are nutrient-rich, providing more nutrients than calories. Then, when I apply my own nutrient-rich food index, which has 9 nutrients to encourage and 3 nutrients to limit, I'm plotting the NRF nutrient density score on a horizontal axis, and notice that milk and dairy are right after vegetables and fruit, which are nutrient-rich not only because of the nutrients they contain, but of course also because of low energy density. Remember, it's nutrients in relation to calories. Protein foods, slightly lower and up on the energy density, and then, of course, sugars and condiments and snacks and sweets and fats and oils, way up to the top left, low energy, high energy density, low nutrient content. So then, looking at prices, take a look at the prices. I'm looking at protein content here in grams per 100 grams and cost in dollars per 100 grams. And notice the low price of dairy products, right down there with beans and eggs. Cheese is the exception. And of course, meats and especially shellfish are totally off the scale. So one more thing, one more calculation of the cost now. Take a look at the cost per 1,000 milligrams of calcium and the percent of calcium intake from different types of foods. Look that in red, most calcium for children above and for adults comes from milk and dairy at the lowest possible cost for calcium. Other food groups do not provide nearly enough calcium, and they have a higher calcium cost. So finally, environmental data. Everybody has been using excellent data from a classic paper by Poor and Nemeczek, looking at environmental impact of foods. Those were data for 129 countries. I want to make 2 points. One is that data on the environment need to be context specific. Data from the Netherlands on dairy products are not the same as the ones from the US, are not the same as the data from India or Asia or Africa. So those data need to be context specific. And then data from Poor and Nemeczek were always publicized as calculated per kilogram of food. No, we need to look at a nutrient-specific functional unit, which means we need to look at maybe 100 grams of protein. And the moment you do that, compare the scale on the left with the scale on the right, beef is no longer way out there. It's all now more closely together. And pay attention to cheese and milk. The greenhouse gas emissions seem to be the same as for cassava, manioc, the major source of poor quality protein in Africa. And then take a look at eggs and poultry and farmed fish. And then you can start seeing that those huge differences per kilogram of food are diminished once you start looking at something nutrition relevant, which is protein. So the 4 dimensions, again, remember 4.2, foods and diets need to be nutrient-rich, affordable, socially acceptable, and appealing with minimum impact on the environment. So thank you. I'll stop here and I will stop sharing.
Excellent. Thank you, Adam. That was quite insightful. We appreciate that very much. Yes, and lots of thumbs up and applause for our virtual attendees. Thank you.
Oh, I love it. I've never seen a floating applause. That's very cool. My first
Yes,
time.
lots of appreciation. And now we'll turn it over to Stefan, and then we'll come back to Laura, who's confident that she's fixed her audio issues. So Stefan, over to you.
Yes, thank you. I hope my audio is okay. Hi, I'm Stefan Peters from the Dutch Dairy Association. I'm glad that my presentation is right after the one of Adam, because Adam just have shown you some data about life cycle assessments in relation to protein content. And I think that was a good idea to see that if you express LCAs per kilogram, that is not the way to go forward when applying LCAs to nutrition advice. Oh, geez, everything goes here. Because my story is going to be a bit technical, I think why not starting with the conclusions that I'm going to present you later. And my story is about life cycle assessments and their translation toward food-based dietary guidelines or food comparisons. And my conclusions will be as follows, that the classical LCAs, as Adam also said, are not being developed for food-based dietary guidelines and also not for food comparisons, because you can imagine that if you replace one food by another, the LCA of your diet will decrease. But it also depends on what food you replace with another when it comes to the nutrient contents. Unfortunately, there's no one-size-fits-all solution for nutritional LCAs, and I'm going to show you that later. And also Adam said the same. All LCAs and also the nutrition context is very context-specific. So we at the Dutch Dairy Association and with some colleagues, we tried to find some potentially acceptable alternatives to LCAs And even for NLCAs, one is called the QI NLCA, the qualifying index NLCA. And another one is a similarity index for food comparisons, and that's a similarity index for food comparisons to compare foods without taking into account LCA. So I come back to that later. Again, what I said, this is the storyline of my story. We are going from LCA to NLCA to, well, hopefully smart and valid food comparisons. Let's start with LCAs. Probably you are familiar with that. What are LCAs? They are life cycle assessments in which you can determine the CO2 footprint per kilogram of a food based on a cradle-to-grave analysis. And based on those analysis, we can indeed conclude that, for example, animal-based foods have got a higher global warming potential or greenhouse gas emission than plant-based foods. Right? But as Adam already said, and I took a picture of one of your slides, so I'm going to repeat what was in your slide about the 4 domains are not additive. One, you said, most nutrient-rich foods cost more and have a higher carbon footprint. Those are mostly the high-quality animal protein products. We see that confirmed in these CO2 footprints expressed per kilogram. The cheapest foods tend to be nutrient poor, that's true. But also the plant-based food with the lowest carbon footprint is sugar, and even the sugary drinks, right? So this is the starting point of the life cycle assessments expressed per kilogram. And why does this lead to wrong paradigms? Because based on this, we got the protein transition paradigm that we have to leave animal-based protein foods behind and replace those by plant-based proteins, foods, because you got a lower environmental footprint. But that is not logical, because it's of course not logical to replace a beef by a banana. Why? Because they have got very different nutritional profiles. So that's why this kind of representation of environmental footprint is not really applicable for food advice and food-based dietary guidelines. So that's why I come to the second part of my presentation, short. The Food and Agriculture Organization said, okay, if we are going to apply LCA values towards nutritional advice, we should include nutrients in the LCAs, right? And this is when they introduced the term nutritional LCA. And what their potential solution would be, if you now replace the CO2 per kilogram, the functional unit kilogram by nutrients, then that might be an acceptable solution. But this leads to complex functional units and a bit of counterintuitive functional units. Why? Because we replace, for environmentalists and also for food policy makers, the kilograms by nutrient indicators. And from the FAO report, I've got this example. Here you see the different foods, and here you see the different nutrient-rich food indices, and these might be very, very familiar to Adam Dragowski. And here, in the FAO report, there are a lot of different interpretations of LCAs. Here you see the effects of applying different nutrient-rich food indices to the environmental footprints. So now we have replaced a kilogram, for example, here, or here by the nutrient-rich food index for 9 nutrients and the 3 nutrients limits. Here with 15 nutrients, 3 to limits, and with 23 to limits. And here you see the interpretation, for example, with milk, that if we go to more nutrients, that the environmental footprint expressed in NLCA outcomes will decrease. So what the FAO said is when we are going to include nutrient or nutrient richness into LCAs, then the nutrient richness the foods are, the lower their corrected for environmental footprint is. But as said, this leads to a very counterintuitive functional unit and very difficult to interpret. But this is the way forward. And as soon as we're going to apply LCAs to food-based dietary guidelines, we have to include the health aspect of foods. Now, as said, the FAO solution is quite a challenging one because it might lead to a counterintuitive functional unit. That's why and now I'm going to show you 2 potential solutions of advancements from NLCAs towards, well, more complex NLCAs or to valid food comparisons. we had made two tools, two different solutions, and I'm going to start with the next one. The next one is going to be our qualifying index NLCA. And what we did here, we also applied nutrient and nutrient content to LCAs, but we did not replace the kilogram by nutrients, but we have the nutrient content as a correction factor for the CO2 content, for the LCA content. So this means if we're going to correct the CO2 per kilogram for nutrient density of a food, then we will still have a CO2 per kilogram as outcome, but a corrected one for nutrient quality. Of course, this also comes with its complications. So let's start with explaining to you what the qualifying index, that's the correction factor that we have applied, what it is. It is in the first place a dimensionless value that expresses the relation between the nutrient density and the energy density of a food. So actually the nutrient kilocal balance. And this is used as a LCA correction factor. And based on the Dutch, and this is from also, again, context specific, based on the Dutch food consumption survey, we determined that these are the relevant nutrients for the Dutch situation, which we have included in the qualifying index. We related those to the kilocals per 100 grams, and that is what we have used as a correction factor for LCAs. So in the end, what does it mean? In general, if the nutrient content is high, so nutrient-rich foods, and the kilocal is low, then we are talking about the nutrient-rich food. And the nutrient-rich food will correct the LCA to a decreased value. And in contrast, nutrient-low foods and calorie-rich foods will correct the LCA to a higher value. Now let's go back to this figure that I've shown you in the beginning. Again, on the left-hand side, nutrient-rich animal-based foods, milk products in the beginning, soy drink as an imitation, plant-based imitation milk, and whole grain, multigrain bread and bananas. And we've also added some extras of condiment. One is cake, one is potato crisps, and one is soft drinks. Years ago, that's also, I think, an important thing to consider, is that we only had database, LCA database of basic food groups and little data on all those extras that we consume. And based on that, we also have come into paradigm that we have replaced high environmental impact foods with low environmental impact basic foods. But maybe we could also change the high environmental extras with low environmental basic foods. But that's another discussion. So let's go and have a look at the correction that we have made based on nutrient quality. And here we see a bit in line with what Adam has shown with the LCA per protein. We have now corrected for the CO2 per kilogram by our qualifying index. And then we see that if we are going to apply the qualifying index as correction factor for the CO2 per kilogram for products, then for a lot of animal-based and especially nutrient-rich products, the environmental footprint decreases, and it stays, of course, a CO2 per kilogram expression. That's on the left-hand side. For cheese, we see a small decrease. For yogurt, milk, and other drinks, we see a decrease. But we see something interesting because these products have low nutrients and high calories. So the contrast occurs here when we apply the qualifying index for non-basic foods, all the snacks and actually all the foods that you probably like. We have to correct the CO2 footprints into a non-beneficial way. So this is a bit of a more realistic way of expressing the environmental footprint if we are going to apply to nutrition. But here we have still applied a one-size-fits-all solution. But we all know that in most food-based diet guidelines, and these are the Dutch food-based diet guidelines, we got different foods with different nutritional aspects. So better, instead of using a one-size-fits-all qualifying index, we said, why not applying the nutrient-specific aspects of the vegetable and food groups, of the cooking fats, of the protein foods, and of the whole grain potato foods separately. So we also developed, based on the qualifying index nutrients that I've shown you before, food group specific nutrient indicators qualifying index. and not going to show especially in specific what those effects, what those nutrients are. But here you see, and we think this is a more and a better correction based on a food group specific qualifying index for those original blue LCI values per kilogram. And here you see again, for the basic foods, when they are, I said when the QI is applied for food groups, that the QI for the basic foods even decreases more for most basic foods. And we do not have food group specific QIs for the snacks and the sweets, because these are not based, these are not the nutrient deliverers in our food-based diet guidelines. So, and another fun thing is that we can also apply our qualifying index not only to individual foods, but also to meals and diets. Here you see a whole meal of French beans, boiled potatoes, chicken fillet, and we got yogurt with strawberries as dessert. These are the portion sizes, and this is the total the CO2 LCA per meal. And if you're going to correct it for the qualifying index, then you see a decrease. And if you're going to correct it for even a more specific food group specific qualifying index, then the CO2 footprint even decreases more for these basic foods. We're coming to conclusions. This has been published a few months ago. The good thing about, we think, the qualifying index and LCA is that the results for correction for nutrient calorie content remains a CO2 footprint or environmental footprint per kilogram of product, as we are used to do. It's applicable for food, but also meals and diets. We can also calculate the corrected for Eat Lancet diet for the qualifying index. A general outcome, basic foods get a lower CO2 footprint per kilogram. Snacks, sweets, another get a higher one. Well, we now have used it, of course, for CO2 per kilogram, but it can also be applied to other environmental indicators. And it can also be used with other nutrient indicators, like the one that Adam just have shown you, the nutrient with factors. But in the end, I think also a general conclusion is that a one-size-fits-all solution for introducing nutrition into LCAs is very, very challenging. That is why we went one step further, and this is what we call the solution Hupperts, because I've developed this with Professor Tom Hupperts, which we have called the cosine similarity index. And actually what we did with this similarity index is that we start again with this figure, but now you could say, if I'm going to replace beef with milk or with bananas, am I making a valid product comparison? How much are these products alike? Now, of course, we have to compare apples with apples and not apples with non-comparable apples. So if you want to change, for example, meat in your diet by cheese or by a plant-based meat alternative, then are these products, when it comes to the nutrient content, alike? Now, we have applied to these foods the so-called cosine similarity index, and the interpretation of the cosine similarity index is quite simple. Actually, the cosine determines the angle between 2 points, and I'm going to start with 2 points and later with 21 points. And then the closer the cosine similarity index comes to 1, the more comparable the foods are. So if I'm going to compare milk with milk, the cosine similarity index is 1, right? And if it's closer to 0, then when it comes to the nutrients, and the 21 nutrients, qualifying nutrients I've been talking to you before, you've taken all those 21 nutrients into account, then you can really compare one product with another and see how comparable they are based on the cosine similarity index. We did that for approximately 200 products, and then that will result in these kind of figures. This is the mother figure with the raw data. But to show you a first version, and this is based on 2 nutrients, not 21 nutrients, you can read it here. Are products comparable? And here we compared dairy products with a soy drink and also with kelp and spinach, because these are calcium products. And why did we include those ones? Just to show to you that comparing products based on 1 or 2 nutrients or 25 nutrients is very different. But based on calcium and protein, you can say that spinach, seaweed, and also soy drink are a bit alike to milk and milk products. But if we now are going to apply this to 21 products, then we see a difference, because taking 21 products into account and applying the cosine similarity index, then we see that soy drinks, which is enriched with calcium, and B2, B12, I guess, and spinach and kelp, which are actually compared to dairy products because of the calcium content, seem to be very different products to the original dairy products. A fun thing is you can do a lot of different comparisons. You can also say, if I'm going to replace milk and milk products with nuts and seeds, is that a smart comparison? Well, here you can see that it is not a smart comparison. And so we can make a lot of different comparisons based on this cosine similarity index. So this is the conclusion of the cosine similarity index. It is useful for product comparisons of individual foods. It does not include the LCA data, but if you say, okay, because of the high LCA value of one food, I want to replace it with one with a lower LCA data, then you can use the cosine similarity index to see if these foods indeed are nutritionally comparable. It gives also nutrition insight and nutrition diversity within food groups, and can be based, of course, on any multi-nutrient index, also the nutrient risk factors. We also made a lot of different calculations, even with individual nutrients. Actually, we need two, and with the nutrient-rich food indices. And the similarity index can help to make valid comparisons between foods. And here we've got another representation, meat and meat substitutes versus meat products versus meat and meat substitutes, and one milk substitute. And here we see that when it comes to comparing, for example, milk with plant-based imitation milks, that the best imitation drink has got a similarity index when compared to milk of 0.4. But with the meat replacers, you can see that there are a lot of different qualities, that some meat replacers have got a high similarity index and some have a low similarity index, and that maybe for some circumstances, soy drink, which has been placed in the market as a milk alternative, maybe can be a better alternative for some meat products than for milk. So, coming back to my first slide and to my conclusions, classical LCAs, again, are not being developed for food-based dietary guidelines or food comparisons. Unfortunately, they are, and that is why we came that strange paradigm of the protein transition. Unfortunately, there is not a one-size-fits-all solution for nutrition LCAs, because LCAs are context-specific and nutrition is context-specific, as also Adam Drafnowski just told you. And there are, if you think really good about it, maybe some potentially acceptable alternatives to LCAs, but they do not come with their disadvantages. Thank you.
Thanks to all of our excellent presenters for the informative presentations. We absolutely appreciate you sharing your insights on the role of dairy and other animal source foods in advancing global nutrition goals and supporting nutrient adequacy across the lifespan and contributing to the 4 domains of sustainable food systems. We will now turn it to the facilitated question and answer portion of our webinar. Please continue to put any questions that you may have in the chat. I see one was in there that was already been answered by Annabelle about some additional reading and resources. I'll open with a few questions to our panelists, and I'll keep watching the chat for new questions as well. Adam, the first question is for you. What do you think are some of the challenges as well as opportunities in communicating dairy sustainability contributions, both to consumers and policymakers?
Well, I think dairy fits in the 4 dimensions of sustainability probably better than any other food group, because we're looking at something that's nutrient-rich, affordable, sustainable, and deeply, deeply embedded in society. So I think that as we talk about the sustainability of dairy, it's those 4 dimensions that make a difference. And dairy is a good fit. I would mention the issue of cost, because dairy is an affordable source of protein, probably more than most, and does provide sufficient protein per serving, not per 100 grams, but per serving. And we're really looking at servings. That's what consumers care about. So think about a serving of cheese, a serving of yogurt, or a serving of milk do provide you with 7 grams of high quality protein for a low cost.
Yeah, thank you for sharing that. It does seem like the challenge has been either not in appreciating the full nutrient component or considering all four domains of sustainability in some of the recommendations being made.
I think that was the fault of Lancet 1.0 because they went directly from nutrition to the environment, missing out economics and society. Those two dimensions need to come back, and I'm not sure they are coming back in Lancet 2.0. We're looking forward to seeing it.
Absolutely. Thank you. Laura, as we transition towards more sustainable food systems, based on your expertise and your work with global authorities like FAO and WHO, how do you think we can ensure that the role of nutrient-dense foods like dairy are not overlooked in policy narratives?
I'm going to try, but I don't think you can hear me very well. Yes?
We can. Yeah, we can.
Yeah, we can.
Okay. I'm so sorry. I apologize. I mean, on behalf of the university, let's say. I think what's important to emphasize again is it is critical in certain life course phases that those animal source foods stay in our diet, in dietary patterns. And that should be reflected in the dietary guidelines. And then the second thing that is important to emphasize as we move toward is just balancing animal source foods across the world. In some places, too much. In other places, not enough. And that is having negative consequences for health. So WHO and World Health Organization have released, what is a healthy diet? And it includes adequacy, moderation, diversity, and balance. And two of those represent the opportunity to keep animal source foods in the discourse. It's diversity and balance. Thank you.
Oh, very good. There is a question about lactose intolerance in the chat. Do you want to address how that plays into recommendations for dairy foods?
Did you want me to address that?
Yeah, maybe first you and Stefan may also want to, or anyone else may also want to answer.
Yeah, I think as you have seen in these presentations, and Stefan can vouch for this, there are other ways to get the nutrients that you need in terms of lactose intolerance. It's not as prevalent as people think. That is clear. And there is, there are other ways to get those nutrients from other animal source foods. Maybe Stefan has more.
Yes, maybe I could give some more nuances to that. We hear that a lot, that 2/3 of the world is lactose intolerant. I think two misperceptions comes out of that. By definition, one, that 2/3 of the world is lactose intolerant. What we see from a more biological mechanism is that there are a lot of lactose maldigesters. And that's something different than lactose intolerance, and those terms are often confused with each other. I think, and actually, in the end, we are all lactose maldigesters, right? What is a lactose maldigestion? Is when your lactose metabolism is overloaded with lactose so that your body cannot digest lactose in a sufficient amount, and that will end into the complaints that people experience with an overload of lactose. And the suffering of the symptoms, that is what's called lactose intolerance. That is something completely different than with the incidences than the 2/3 of the world. That's one. So a lot of people that are lactose maldigesters can tolerate to a certain extent lactose. Second, and I think there's another misperception is that, and also used earlier by people of Eat Lancet and other people that are making more plant-based, food-based diet guidelines, they say people that are lactose intolerant, in the end, the majority of those people are lactose maldigesters, cannot consume dairy products, which is nonsense.
Yeah.
A lot of different dairy products have different contents of lactose. Most lactose intolerant people, even intolerant people, so the maldigesters and intolerant people, can just consume cheese because most of the lactose in cheese has been digested already by the beneficial bacteria. Also other fermented products. And a lot of people that suffer from lactose intolerance in circumstances can also drink a glass of milk. Do not drink 2 or 3 and you can adapt yourself. And then a final point, when it comes to dairy and food-based diet guidelines, we hear this also a lot of also from a famous professor of the Harvard University affiliated with the Lancet, that in a lot of countries, dairy is not advised. In contrary, we have an overview with IDF for those who are interested in it. We've got an action team on food-based dietary guidelines, of which you are the chair, Katie. And oh no, Ashley is the chair, but it doesn't matter. We've got an overview of all food-based dietary guidelines worldwide. And what we see in China, Indonesia, India, the milk and dairy product advices are approximately as high as in the Western countries. Why? Because they acknowledge the health effects, not only the nutrient content, but also the health effects on dairy, on non-communicable diseases, beneficial on the one hand, and the nutrient content, and they recognize that in their food-based dietary guidelines, of which we, as in the Western society, say that those population are lactose intolerant. We know in China, just one example, the average consumption of dairy products is below 100 grams of dairy products a day, while their food-based dietary guidelines advise between 300 and 500 grams of dairy products a day, independent on the fact that there are a lot of lactose maldigesters.
Yeah, we thank you for acknowledging the food-based dietary guidelines work that IDF is doing. We track every country that has food-based dietary guidelines, and the vast majority do include dairy recommendations. Dairy has its own food group and daily consumption. So we do see it going back, centuries of what's part of contextual country foodways around the world. So thank you for sharing that. As this relates to Eat Lancet 2.0, Adam, you were speaking a little bit about some preview of that from recent conferences you've been at. What are you anticipating stays the same or maybe different in the approach to the Eat Lancet 2.0?
There were three issues that were being raised before. One was the affordability. The second one was lack of the social context. And the third one was the insistence of a single unitary planetary health diet. And I think right now the territoriality will be taken into account by giving ranges of foods to be consumed depending on the continent, culture, tradition, and so on. But I don't see any major changes announced about the affordability or the social, I call it embeddedness, or the social value of food. Remember, Lancet 1.0 came under severe criticism from IFPRI, the Institute for Food Policy Research, because the Lancet diet was found to be not affordable by 3 billion people. That's a major flaw for a planetary health diet. Now, who is it for, really? So I think that the territoriality will be addressed, but I'm not sure about the other things.
Thank you for that. Some of the Eat Lancet 1.0 commissioners were on papers that, elevated the lack of contribution of the Eat Lancet 1 in solving for micronutrients, the micronutrient needs of the general population. Do you see that that's addressed will be addressed in the 2.0, or will that still be a shortfall?
Well, I'm not sure about that because it was never revealed what nutrient composition database was in fact being used. So based on calculations using other databases, including the FAO West Africa database, the Lancet proposed diet was deficient in some key micronutrients and very marginally deficient in protein once you correct for protein quality, because most of the protein was coming from plant sources. So the Lancet diet was 80% calories from plants and about 66% of protein from plants without necessarily adjusting for protein quality. So I don't know what database was being used. I'm not quite sure how it was corrected because those details were kept private, so we don't know. But as I say, using the FAO West Africa nutrient composition database, we confirm previous findings of nutrient deficits in the proposed Eat Lancet diet, yes.
Very good, thank you. There's a question in the chat. Has food waste been discussed for Lancet 2.0 in terms of environmental impact? Does anyone have a perspective on that?
I'm looking forward to finding out. I think the reveal will be in October. And I think we just got a little preview at ICN, not giving all the details. So we'll see. Stefan, do you know?
Yes, I can.
Yes.
I've talked to one of the people worked on it, and in general, he said the following, and I cannot go into too much detail, that with only changing, yes, there were three aspects of going towards a Eat Lancet diet that fits within the planetary boundaries, right? One is, of course, following the advice Eat Lancet diet, which is actually a nutrient inadequate diet, because that's one. Two is changing the production, right? Making the production more efficient. And three, taking into account that food waste should be decreased. And all those three things together might potentially theoretically lead to a food production system that can be, as I said, that fits within the planetary boundaries. It's not one of them, but all three of them have got to succeed. That is the conclusion of the Commission of EAT.
Absolutely.
Can I add
Thank
to
you.
that? There is one more
Yeah.
issue, and that is the consumption of animal proteins in the world is determined by economic status of a given society. To some extent, the consumption, of a very large extent, the consumption of meat and eggs and dairy is aspirational, and it increases with rising incomes no matter what we do. So what we do here in rich countries may be completely ineffective in the rest of the world because of the economic forces beyond our control. Something to think about.
Yeah, very good. Laura, as you know, your work with FAO and WHO, how much do you think we could inform, or they are taking into consideration, those who inform dietary recommendations to consider all four mains of sustainable food systems?
Yes, we work closely with FAO, and I would say that they are certainly considering all food groups and the importance of balance and diversity. We're doing a lot of work right now actually on biodiversity and the importance of that, the bidirectional relationship with human diets and diet diversity, which I think will be, will at least contribute to that planetary boundary understanding at a deeper level. I mean, one other point I want to make, and maybe Adam or Stefan heard this at ICN, but I did not hear, again, the recognition of the different nutrient needs across the life course in the Eat Lancet. And one, that was one critique I think that was leveled in the first Eat Lancet, which is that we didn't consider, we're just looking at adult diets, and that healthy planetary health dietary pattern is for adults. It doesn't consider pregnant and lactating women. It doesn't consider older adults. And most importantly, it doesn't consider infants, children, and school-age kids. Those are life course phases where source foods are critical.
Totally agree.
I've heard the presentation of the clerk at IONS, Adam. I don't know if you've heard his, and I think he said that they wanted to give some more advice for vulnerable groups, but how that effectuates, I do not know. But I want to stress one thing. We just a few months ago, and we are starting this. We are now in the middle of the project. We have calculated the nutrient adequacy of food-based dietary guidelines of 10 countries and Eat Lancet. And what we found is that when it comes to the nutrient adequacy, most food-based dietary guidelines, when you translate the final advice to the consumers, when you calculate those back, are still not nutrient adequate. And I think there's a big warning also for the Eat Lancet committee, because if we look, and I think most of you that are familiar with the GAIN study of Ty Beal of the nutrient adequacy of 6 nutrients or nutrient inadequacy of the 6 nutrients of Eat Lancet, we have to realize, I think the reality is worse, because you have to realize when calculating an optimal food-based dietary guidelines to nutrient adequacy, we work with so-called optimization models. And that means to fit your total diet into a nutrient adequate diet, we are including nutrient-dense foods and then calculated whether that nutrient-dense diet fits within food-based diet guidelines, right? And fits within the planetary boundaries. On the other hand, imagine those nutritionists among you know that if you are going to set DRVs, so daily recommended values for vitamins, You've got the average, right? The 50% advice, the estimated average for people. And then we add 2 standard deviations, so that in our advice, 97.5%, if they follow this advice, of the population are nutrient adequate for that individual nutrient. This is not what we do with calculating food-based diet guidelines. There we estimate that half of the population in most optimization models are nutrient adequate. And this is not the way how we should calculate or determine the nutrient adequacy of food-based diet guidelines. And I was talking to some of the people of the DGAC, so the American Food Authority, and I've shown her my results, and she said, yes, Stefan, you are right. We are calculating with nutrient adequate food. And what we see when we get that nutrient optimal model, then we translate that to what Eat Lancet do, to 1 portion of meat per day or 3 dairy, that. And we see that if you translate that to realistic diets, then we see, and I will never forget it, and that will be the title of our article, then we see nutrients lost in translation in food-based diet guidelines. And that's the issue also and with Eat Lancet. And of the 10 countries, including Eat Lancet, when it comes to nutrient inadequacy, Eat Lancet was number 1, far beyond the other 10 countries.
Yeah, thank you for that. I mean, there certainly is room for improvement in our diet quality for sure. We are at the close of our time. Thank you very much to Drs. Iannotti, Dranowski, Dr. Peters for your insightful conversation today. For all of you who contributed comments and your appreciation in the chat, thank you so much. Following the webinar, we'll share the link for the recording with all the attendees, as well as some follow-up resources from the speakers related to their presentations. Thanks everyone for joining today. Have a great rest of the day.